All right, let's look at some applications here. This point, okay, we have a point moving along this curve, and we know that x is, with respect to t, is changing at 2 centimeters per second. We want to find how is y changing with respect to time when x is -2. So we'll start in, we need to find dy dt, so we'll start right into this function here. Dy dt equals, now I'm going to view this, and before I start my derivative, I'm going to view this as 1 plus x squared to the -1. And the only time I do this is if I have a constant in the numerator, then I will convert to this form with a -1 exponent before I do my differentiation. If this numerator is variable, then I usually will not do this. But since it is a constant, I'm going to do that first. Now my derivative coming here, I have -1 plus x squared to -2 times the derivative of the inside now, because this is the chain rule. We have a function raised to a power here. So I'll end up with the derivative, which is 0 plus 2x times dx dt. Now, so this is different from what we had before when we were treating x as independent. And then I would find dx, the derivative of x squared with respect to x is just 2x, but with respect to t, it's 2x times the dx dt. Okay, so the derivative, I now have to differentiate x as if it were a function of t. So I'm using a chain rule, not only on x, but on y also. I'm sorry, not only on y, but on x also when I see these in my equations. So I have an added level. So now let's go ahead and rewrite this the best way we can. Let's see, it looks like we have a 2x. Well, I'm gonna make that a -2x dx dt over the 1 plus x squared quantity squared. Okay, so that's everything. Now, I can calculate that at whatever values I want. So let's go ahead and I'll write this dy dt. Okay, so dy dt when x is -2 is equal to -2 times -2. Now dx dt, remember, is a 2, so that's a 2 up there. And then down here I have 1 plus 2. Well, it's technically a -2 squared. And then that's squared. So that will simplify to 8 over, looks like 5 squared. So it's 25. Okay, when x is 0, y dt when x equals 0 becomes a 0. You can see that right away in my function here. Comes a 0. When x is 2, let's see, I'll do it here. Y dt when x is 2 becomes a, again, using this function here, -2 times 2 times times another 2 over the 1 plus 2 squared. So that's a -8 over 25. All right, so that's everything. And notice the notation that's convenient to use with that vertical bar. Okay.